Hello and welcome to this session on data and analytics. My name is Javier Ramirez. I'm a developer advocate at Amazon Web Services, and my mission is to give you as much information as possible so you can build your services on AWS. If you have any questions after watching this talk, feel free to ping me on Twitter. You have my information there on screen, SuperCoco9, and my private messages are open. Today, I'm going to tell you how we go from having raw data to having actionable business insights. I'm going to tell you some of the challenges you're going to find when working with data and how AWS can help you build a modern data lake. And by now, everybody agrees that data is a strategy for every organization. But until recently, data was not something that everybody used in the organization. It was reduced to some departments, like, for example, business analysts or data warehouse engineers. But we all agree now that the more data you can have across all the departments, the better for your organization. For example, if you are into IT operations, you can explore your historical data to do some insights. Or if you want to start with machine learning and you need to create a data set, you need to have some way of capturing and transforming and validating your data. If this is the first time that you are exposed to building a data engineering operation, it might be the case you don't understand the difficulties or some of the things to take into consideration when choosing a way of doing analytics. So let me just give you a brief introduction based on my own story. Uh, 10 or 12 years ago, I was not a data engineer. I was working in web development. And back then, my data tolerance were very unsophisticated. I would have a few thousand users on a database, and if I wanted to run a report for all of them, of course, the database will slow down. But then I discovered more interesting problems. For example, that a lot of interesting data was living outside of my database, like the log files or the web analytics or the PDFs and emails from users or images, and I would need some tools to work with that. And luckily, at the time, Hadoop came and helped people analyze data that was too big or too unstructured, which is super cool. But Hadoop was not really well adapted to fast-moving data. And with more and more mobile devices, with more and more mobile applications, with more and more with better bandwidth at home, with the industrial internet, we started seeing the need for fast-moving data. So we saw new tools, message queues, NoSQL databases to capture data at speed. But it was not enough to capture data at speed. We would also want to actually analyze the data at speed and get results in seconds, not in hours or days, as it was the case in the past. So we saw again new tools to work with real time. And we saw also something very interesting. We started to see that data was not only something you could access with using Java, but you could also access with Python and other languages. And this brought the explosion of data. More and more organizations, more and more people would have access to work with data. And that brought interesting problems with it. For example, now that we have so much data available, we need to have some way of making sense of the data. We need to have a way of making sense and cataloging the data. We need to understand which data is already available in the organization. And since data is not static, since it's going to be changing all the time, we need to have some way of versioning the data and keeping track of the changes throughout time. And if this was not enough, we are adding constantly new capabilities to our organizations. For example, a few years ago, no one was thinking of machine learning. And now everybody wants to have machine learning in the organization. If you are working with a traditional architecture, it will be very difficult to integrate machine learning into your workflow. So when you are designing your data engineering operation, you need to build something that is flexible enough to accommodate to the new technologies that can appear in the future. So in general, customers want to have some kind of structure in which they can grow as much as they need. They can ingest and process data from different sources. This data is not going to be uniform. It's going to be in different shapes, in different formats, different speeds. We are going to be using the data by virtually everyone in the organization, and it's going to be processed by many different applications. The bad news are traditional tools like a data warehouse are not going to cut it here, because traditional tools, they don't really scale well, and also they are pretty rigid. They need to work with very structured data. So more and more, people have been moving lately to something called a data lake that allows for much more flexibility when working with data. When you work with a data lake, you can keep doing reports and traditional analytics as when you were using your data warehouse. But you can also do predictive analytics, you can also add machine learning, and you can do virtually any type of analytic on top of your data lake. A data lake also allows you to scale as much as you need, even to exabyte scale. And a data lake is not just a repository of information. Sorry, if you are treating your data lake only as the place where you have all the information, that's only the start. A data lake should also allow for self-service. And by self-service, I mean if I am the person that needs to use the data, I should be able to query the data myself. In the past, when someone from the business wanted to create a new report, it will have to come to me, to the data engineering department, so I will create the report. And I will introduce a lot of friction, a lot of delays. So you want the person that is going to be using the information to be able to access the data lake and query the information by themselves. And you also want your data lake to be able to support new tools in the future. You don't want to have to rewrite everything just in order to accommodate a new type of analytics that you can think of a few years from now. The good news are, if you want to build this using open source, it's totally possible. You can install some of the tools or all of the tools you can see on the screen right now, and you will have a perfect data lake. It will allow for batch, for streaming, for real time, for business dashboards, for monitoring, for security, for machine learning, everything. And by the way, I've used all of these tools in production, or at least as a proof of concept, and I really like them. They are super cool, and they are powering the analytics of thousands of organizations. The challenge is, when you have some of these tools or all of these tools together, it's quite complex to manage. You have to spend a lot of time in configuring, maintaining the infrastructure, upgrading to new versions, upgrading security patches. And by the time you have a system which is up and running, and it can take months until you have a system fully configured, up and running, your users are going to start running their workloads in the system. And it makes very hard to update, because once you have workloads running in your system, you don't know if upgrading is going to be breaking any of the existing workloads. And it's not easy to duplicate in a second system. So, it's going to slow down your innovation capacity. It's going to make it difficult for your team to experiment. So, is there a better way to do these things? Well, a possible solution could be using the cloud native services on AWS. On AWS, we give you many different services for data and analytics. Some of the services have been purpose-built on AWS, and they run fully serverless, so you don't have to worry about any servers or about anything else. Some of the services we have are built on top of open source, and some of them are just open source, which is managed by us. So for example, if you want to use a Hadoop or Spark or Apache Kafka or Cassandra or Presto, you can just choose to run those solutions on AWS using our managed services. And by using our managed services, we are going to take care of the infrastructure, so you can focus on the business logic of your applications. You can focus on the things that are important for your business. Because let's face it, if you have a cluster and it's running out of storage, you don't need to have one person monitoring that and manually adding more capacity. We can do that automatically. Or you have a cluster with a number of servers, and suddenly you see you have a lot of users and it's slowing down, you will actually add more servers directly on demand without needing to have someone monitoring that and doing that manually. So there are a lot of things we can help with on managing the infrastructure so you can focus on the other things. Same thing with configuration. We can offer you a set of integrated tools that work well with each other in one particular configuration, and you can easily create a new staging infrastructure to test if everything was fine. If not, you can iterate. So, with cloud, you can optimize the work when you work with data, and you can overcome many of the difficulties that you will get when you try to manage data on your own. And if you choose to move to AWS, you are not alone. We have many customers using our services. We actually have more data lakes and analytics running on AWS than anywhere else. And when we ask our customers why they are choosing AWS for the data lakes and analytics, they basically tell us 4 reasons. The first one, because it's pretty easy to start with. And I'll show you a demo later, and you will see how easy it is to build a data lake on AWS. The second, of course, is because it's very secure. Another reason is because we are compatible with open tools, and we have a very comprehensive offer of services. And the fourth reason is we can scale as much as you need, and we are quite cost effective. So on the first part, on how easy it is to build data lakes and analytics on AWS, you might be aware of something called Amazon S3. Amazon S3, it's a solution to store data at any scale on AWS, and you can use Amazon S3 to power your analytics and machine learning workloads. So it sounds like a good foundation for a data lake. But if you wanted to build a data lake using only S3 and managing everything by yourself, it will still take a while. But we offer something called AWS Lake Formation that allows you to configure everything you need for building a data lake from a single point. You can configure the security, access, you can configure the ingestion pipelines, you can configure the transformation of the data, you can configure the cataloging of the data, and you can expose the data to analytical engines, everything from the single point. And since S3 is fundamental for AWS, every solution in AWS that has to do with data analytics can integrate with S3. So you have the flexibility to have your data in S3 and then choose which of the services are better for your different workloads. So you can mix and match. With this solution, you can actually build a data lake in just a few days rather than in months that it will take with a more traditional approach. But don't take my word for it. Let's see what Zalando did with S3 and data lakes. You might be aware, Zalando is a very large online fashion platform in Europe. They serve customers in 17 countries. And of course, they already had their own data lake, and they had a lot of other data, like web tracking data, which is super important for them. And they decided to move from the traditional data warehouse to a data lake architecture. And in that data lake architecture, they wanted to store not only the data they already had on the data warehouse and on the web tracking analytics, but they also wanted to store all the communications across all the services running on the platform. We are talking about 15 petabytes of data. We are talking about 400 teams accessing that data. And we are talking about 8,000 S3 buckets. It sounds quite big. Well, it took only a team of 9 people, very smart people, but a team of 9 people to build a data lake for this solution, which is not too bad. When they were evaluating which cloud provider to use, in the end, they chose AWS because of durability, availability, scalability, but more interestingly, because they saw the breadth of services on AWS as a competitive advantage that they could leverage in the future. And just to show you an example of how AWS can help you, when it comes to S3, we have different storage tiers. Depending on your access patterns, you can store data on one tier or another, and the pricing model is different. When you have this amount of data, it's very difficult to understand in which tier you should put your data to be more efficient. So on S3, we added something called intelligent tiering, which basically, with a click, you can just tell S3, if some of my data hasn't been accessed in the last 30 days, move it to a cheaper tier. And if anyone is trying to access the data which was on a cheapest tier, automatically move it to a standard without having to do anything, without any performance impact. We just do that and it works. Zalando activated that and they are saving now 37% annually in storage, which is not too bad. But of course, it's not only about easy and cost efficient, it's also about security. Security is our number one priority. And the cool thing about moving to AWS is that on AWS, we offer exactly the same security services to all our customers. So when you are into AWS, we have access to the same tools that we offer to our banking customers, travel industry, accommodation, utilities industry, public sector, exactly the same tools. So we give you tools, of course, to deal with monitoring of security and threat detection. We give you tools with dealing with identity and with single sign-on. We give you tools with dealing with encryption at every stage using your own keys or the AWS managed keys. We give you the tools for auditing and compliance. And when it comes to compliance, we keep adding certifications all the time so we can help you meet your compliance requirements for your company. I told you the third reason why people choose AWS, and it was one of the factors actually for Zalando, is the comprehensive set of services we offer. We offer services across different layers. Of course, we have services to migrate your data, batch or streaming. We have services to secure, store, and catalog your data. We have services to analyze your data in different ways with Amazon Redshift for data warehouse, with EMR for Spark or Hadoop, with Athena for serverless operations, for Elasticsearch for operational queries. And we also offer a layer on top in which you can analyze your data, visualize your data, engage with customers, and do machine learning. So many different services that you can leverage for your business. And these services are either based on open standards or they expose open formats so you can interact with them and you can easily move your existing workloads into AWS, or if you choose, move your workloads from AWS to elsewhere. Because that's the cool thing about open source and open formats, that you can actually have the flexibility to move at any point you need, and you don't need to learn the new tools. You can just leverage the infrastructure we manage and still keep using the same knowledge you already had. But I've been speaking for quite a bit here. Let me show you a demo how to build a simple data lake on AWS. Okay, so there is a public data set, very popular. It's called the New York City Taxi and Limousine Commission. They export a CSV file every month with the taxi rides in the city of New York. I have copied all the data for the yellow taxis in New York for the year 2018 to one of my S3 buckets. And as you can see here, there is one CSV file for each month, and each file is about 700 megabytes. So in total, this is about 8 gigabytes of data on this data set. And I want to put this data into a data lake and do some analytics on top of that. So I can go to something called, here it is, lake formation. And I'm going to tell lake formation I want to work with that data in a data lake. So the first thing I'm going to do, I'm going to crawl the data, which means I'm going to be telling lake formation to make sense of the data I have on this bucket. I'm going to be configuring for S3. I could configure actually with different data sources, but in this case, my data is on S3, so that's good enough. Here it is. I don't want to add any other data store. I could create a new role for the permissions, but I'm going to choose one I have already with the permissions I need. And I could choose to run this on a schedule or just on demand. I want to run on demand. The last step is how am I going to catalog this into the data lake. So for the catalog, I'm going to choose a name here, demo database summit, okay? And with this, I'm ready to just work with the data. I'm going to tell AWS to execute the crawler I just created. And what this is doing, you can see here, it's starting a process. This is going to start a process. It's going to check the data I have on that S3 bucket, and it's going to see if all the files I have on that bucket have the same format. Since it's CSV, it's going to check that they have the same number of columns, they have the same column names, and they have the same types. If all of them have the same types, it's going to catalog all the files as a single table. If I have different file types, it will catalog different file types into different virtual tables. So it's going to automatically make sense of my data without me having to do anything. And it can do this not only with CSV, but also with JSON, with Parquet, and with other file formats. Crawling the data, it takes a little bit. It can take between 1 and 2 minutes. It really depends. So I'll show you later when it finishes, but I ran already the same job just before I started the recording, so we could see it like, finished. So I'm going to just go to my databases here, and I'm going to show you the table that I discovered before. So as you can see here, we have a table. The data lives on S3. I have these columns that are the columns that are on the CSV. And if tomorrow I run this crawler and it detects a change on the schema because a new file has like an extra column or something, it will catalog the new version with the new schema. So I will be able to always see how the schema has been evolving. But more interestingly, apart from being able to see the metadata, I can actually see the data I have on those files. And when I click on View Data, it takes me to see the data. But you might be expecting to see just rows and columns, but no, I can actually query my data. So let's recap. I have only point lake formation to an S3 bucket. I didn't copy the data. I didn't ingest anything. I just catalog the data. And now I can run queries that run directly on S3. So this query is running on 8 GB of data on CSV on S3, and it's telling me I have almost 103 million records. And of course I can do any query I want. I want to find the records in which the distance of the trip is more than 100 miles. I run the query, and in a few seconds, I should get the results. And here it is, 364 trips which are longer than 100 miles. And this is running directly on S3 without me ingesting the data. We could also, if we wanted to have some business dashboards, we could use QuickSight, which is our dashboard solution, and I could point QuickSight to my dataset to create business reports like this. And the way to create the report is the same way in which you create a report on a spreadsheet. Just point and click, and you select the data types, and you configure anything you want, and you can get reports in a very simple way. So hopefully, oh, by the way, before I finish, I want to show you that actually the crawler we were doing before, it actually finished. It discovered one table, and if I go here, I can see that actually the table was discovered with the same structure as the other because it's the same files, okay? So you can see everything is working together. So hopefully you've seen how easy it is to create a very simple data lake on AWS. The cool thing is if you have more data, you do it in exactly the same way. So you have more data, we scale, but you don't have to worry about that. And it can be very cost effective. For example, what you saw, you only pay for the storage, you only pay for the seconds in which the crawler is analyzing the data, and you only pay when you are running a query. If you are not running any queries, you are not paying for any servers. You only pay for the storage. That's it. So it can be actually very, very, very cost effective. And if you are using other services, you have other ways of saving, like for example, reserving instances, going with a saving plans, or using spot instances that help you reduce the cost in your installations. And for example, if you are using Hadoop, we have EMR, which is a Hadoop compatible service. It's managed Hadoop. And by using EMR, you can save 57% over a traditional on-premises solution, according to the IDC report. Or you can choose to use Athena and QuickSight, which is what I just showed you on the demo, which is fully serverless and you only pay for what you use. Or you can choose to use a traditional data warehouse, like Redshift, which is a data warehouse for the cloud, and it's still a fraction of the cost of running a traditional data warehouse on premises. We have a customer, CAF. It's a Spanish company, and they build subway, intercity, and high-speed trains. They are present all around the world, and they manage many fleets also in Europe. They built LeadMind, which is their solution to manage fleets and to monitor what's going on in the trains. With LeadMind, they can analyze the performance of things like the air conditioning in the trains or the effectiveness of the brakes, for example. Initially, they built the solution just with Redshift, and then they also add Athena and EMR for different types of analytics. They are using this solution to monitor data from 26 different fleets in over 1,000 trains. Each train is collecting 10 to 20,000 variables at millisecond frequency. A typical workload for them is a train sending 15,000 data points every half a second. And that means that every day, every train is sending almost 1.7 billion data points. And they can manage that with AWS with no issues. The interesting bit is that they managed to reduce the breakdown rates and to improve the maintenance. But more importantly, as the managing director tells you here, their data scientists now, they have more time to focus on other things. So you are not only saving on infrastructure, you are also saving on the time that your people can dedicate to do other things that can have more impact for the business. And you might be asking yourself, does this scale? How does it compare to other things? Well, a few years ago, we released an extension to Redshift that allowed the data warehouse to query data directly from S3, from the data lake. And for that demo, we had Werner Vogels presenting this use case. Imagine you want to query an exabyte of data, which is a huge amount of data. Okay, you remember Zalando? They have only 15 petabytes of data. An exabyte will be 1,000. So it doesn't make sense to analyze an exabyte of data with a query. But imagine you want to run a query over an exabyte of data. And imagine you want to run this on open source with Hive on premises with 1,000 nodes of Hive running the query. How long do you think it will take Hive on 1,000 nodes to query an exabyte of data? Well, this is an estimate. We didn't do it. It's totally unfair. I'm sure if we optimize Hive, you could get down to 4.5 years only, not 5 years. And it's totally unfair because Hive is a super cool tool. I use it all the time, on top of AWS also, by the way. But the trouble with Hive or any other tool, they are not prepared for this scale. Reading an exabyte of data from the hard drive is super difficult. Well, not for Spectrum. Spectrum can do this in 155 seconds. So things that in the past would be impossible, now with cloud are possible. And that's all I have for you. If you are interested and you want to learn more about what you can do in analytics with AWS, I invite you to visit our training and certification website. And if you are thinking of starting doing analytics and you would like to explore partners that can help you build your solution, please visit the Discovery Zone on this event so you can know partners in your area. Thank you very much for your attention. As I told you at the beginning, I'm available on Twitter. Have a good day. Bye.